Melissa Braaten has been teaching adult numeracy for the past 8 years in Dorchester. That's how you say it, right? Dorchester, Massachusetts, to adults with all levels of math ability and confidence. She also works as a consultant for the SABES, which I never knew what it stood for. System of Adult Basic Education Support, PD Center for Mathematics and Adult Numeracy, which means she works with them. As part of the SABES team, she works on developing and facilitating online and in-person trainings for ABE and ESOL teachers. Her 3 statements: she spent the summer working with radioactive materials. No big whoop. She loves to bake and decorate cakes. And she did her graduate work in systemic theology.
Systematic theology.
Aha! That was a test. She corrected me, so I know that it's true. Put your hands together.
So now you don't know if I'm a baker or if I'm radioactive. All right. There's me, and you can see Donna in the background. Wanted to show my association. Okay, so thank you for coming and listening to my talk. As a math teacher, like I'm sure many of you have heard, I have a lot of students, whether it's I'm just meeting them or they've been in my class and they tell me, Melissa, I can do the math. I just hate word problems. I just can't do them. I can do the math, but I can't do word problems. And so as a teacher, I want to get underneath that and say, what is going on? Like, why is it that they can't do these word problems? And, I've always had a sense that it's probably a lot of reasons. It's probably not one thing. So there's a lot of things over the years that I've sort of investigated, and, sometimes when students come to me and say this, and I work with that student a little bit, I think, actually I think this student has sort of a shallow procedural knowledge of some of the math, and they really don't know how to apply it, so we need to work on that. Sometimes I suspect, it might be a reading issue. Maybe they really can't read the word problems very well. Or it could be a learning challenge in terms of some students struggle with executive function. They don't know how to plan out a multi-step process and execute it. Sometimes I think, I wonder if this student has working memory deficits, because there's a lot of pieces to hold on to when you're working through some of these problems. So there's a lot of different things I've looked into, and different students have suggested, as I've worked with them, have suggested different things. But I've also had some students that actually didn't seem to fit any of those things. And then there were a couple in particular that just really got me thinking, where I actually did have a sense that they knew the math. Like, they could explain it to me, they really seemed to understand it, they could apply it in various ways, and their reading skills were also very high. So I started asking myself, what else could be going on? In addition to all these other potential pitfalls, is there something different about reading math questions that's different from other types of reading that we have to do? And I suspected there was, but I wanted to do some little informal investigating and experimenting, which, since I'm still teaching, I'm able to do on my classroom, which is great. So one day I put this up before class started. And I was sort of puttering around and setting up and just sort of watching to see what people were doing. And I noticed a lot of people starting to calculate and doing some work, so I just kind of watched. And then when it was time to start the class, I said, we're going to get started. And I noticed a lot of you, it looked like you were doing some calculations. Can you tell me about what you were doing? So, folks explained what they were doing, and most of the people who had been calculating were answering some version of this question. How much will it cost to buy supplies for all the students? So that actually didn't surprise me very much, because I thought that was a fairly logical inference from the situation that I gave them. But what did surprise me was that many of them didn't notice that the question was missing. And they were really surprised when I pointed it out. And I said, did you realize there wasn't actually a question there? So that made me think, well, if they're not actually noticing if the question is missing, I wonder if they're also noticing that there could have been other potential questions that go with this scenario. This was one logical inference, but I could have asked how many folders are needed. I could have asked how much do you pay for each folder? I could have asked, how much more will St. Mary's spend on notebooks than on folders? So I started suspecting that if they weren't sort of reading closely enough to notice that the question hadn't been asked, they might also be missing some of these nuances and differences between different potential questions, and some students weren't even really aware that there were many potential questions. They kind of jumped to whatever one seemed like the most logical. So I wanted to try to find a way in my own classroom to assess this sort of mathematical reading ability separate from whether they could actually solve the problem. So what I did was I took some high school equivalency type questions. Like I rewrote them myself, but they were based on things that I found in different practice tests. So here's an example, and I'll let you read it for a minute. So I took this typical type word problem, but I didn't give them answer options. Instead, what I did was I gave them options of different paraphrases of the question and asked them which one was asking the same thing. So for example, I gave them, how many tiles come in a box? What is the area of the classroom that will be covered in tile? And how many boxes of tiles will it take to cover the area of the classroom? So I gave them those three questions, and I said, which one is asking the same thing as the original? So this was one I ended up categorizing as an easier question because when I gave this, I did a pre-test and a post-test. 81% of the students did get this question right. They identified that it was asking about boxes of tile. But that still means that about a fifth of my students were not able to do that. They didn't identify that those questions were the same. Here's another example of one that I ended up categorizing as it must have been harder. People struggled with more. So give me a moment to read that. All right. So that was the original, and then these were the options I gave them. How many folders will St. Thomas need to buy for September? What is the cost per folder? Or what is the cost to buy 4 folders for 1 student? So this was one that people struggled with a lot. So let me make sure I got the numbers correct. So there were 38% of students got this correct on a pre-test. So this one was a lot more challenging. And if you're curious about, the data, as you should be. So I had 16 people. So these percentages are out of 16 people that I was able to pre-test and post-test. So small sample size, but. So anyway, people struggled with this one, and the most common wrong answer was A, which I thought was interesting because it's asking about folders and not even about money. So there was just a real disconnect going on with this. But what was also interesting to me was that I felt like the scenario itself was fairly accessible. Like people understood things like buying quantity of things and how much do you need. So I wondered if it was something about the language of the question and the fact that it's using the word per and it's talking about a rate. And even though I felt like students would understand the concept of rate, like you pay this much for 10 folders, they weren't seeming to identify that that's what this was talking about, that this was a rate. This was one other thing I thought, the syntax of some of these ways that we talk about parts and wholes can be very, very complicated. So when I gave this as part of the sort of pre-assessment, every student, they're all my math students, and we all talked about a half. So they all really were pretty well versed. I felt pretty confident that they understood the concept of a half and how to find a half. And I tried to choose some pretty friendly numbers. And I was really trying to just test whether they could understand the syntax of, which one was the part and which one was the whole. Some people got them all right, but there were a lot of people who didn't. I think the average was like 2.7 or something. So that means people did struggle, and you could tell if they were struggling with the syntax because, a lot of people said they're all true was generally the thing that put them on. One last thing that I was thinking of in terms of like syntax and things that come up grammatically, and this kind of relates to some other examples I've seen today of people talking about keywords and how they can be deceptive, was this idea of quantities that are more or less, or these comparisons, and identifying like which one's actually actually more and which one's actually less from that syntax, and then which quantity represents the difference between them. So I deliberately gave them one where it had the word less in it, but it actually would require you to add because you're given the smaller quantity. So I wanted to see if they could parse that out from the language. And again, some people could and some people couldn't. So I said, all right, well, I think there's some issues going on here, so is there anything I can do about it? So I created 5 one-hour classes to address some of these specifically. I wanted to see if I instruct people in some of these, like how to connect the syntax and the language to these concepts, if that will help them with this. So we looked at identifying the unit in a question. We looked at connecting rates with language like per or for every. We talked about the syntax of part-whole relationships and the syntax of comparisons. And I want to be clear, I wasn't trying to teach them like keywords, like if you see this, you do this, because as you've probably heard if you've been to a lot of the Numeracy talks today, that that can be very misleading and often lead students astray from reasoning. What I wanted them to do was to understand how to read the syntax and envision the scenario so that they could then reason to what would be appropriate to do. So you're probably wondering, well, did it work? A little bit. I don't want to overstate. Like it was, I did see some improvement. So the first question that you saw that I said was the easy question went from 81% to 100% correct. So there was definitely some improvement on that. And the second one that was like the rate question that was more challenging went from 38% to 50% correct. So there was some modest improvement, but it really made me think about, are there other ways that I could assess this? Are there other ways that I could implement this that might be more effective? Like, I don't know if doing it as separate one-hour classes was the most effective way to do it. It was just, I wanted to try something. So, my challenge to all of you is to try something and to think about ways that you could try to assess your students' understanding of how the grammar of these math questions connects to math concepts, especially if you see a disconnect between concepts they understand, but they don't seem to be able to recognize how they appear in the language. And to try some different things. I mean, this little experiment I thought had some modest success. I didn't think it was overwhelming, and I don't know that I would repeat it in exactly the same form, but I learned from it. And so I want to encourage you to try some things, like always have an experiment going. And then share what you learn with others, because this is something I think every teacher has encountered and we all wonder about. And I don't think there's any one fix to this word problem thing. I think it's going to be a lot of different explorations to get there. So that's what I have. Thank you very much.